esteemed dignitaries, chief guests of today's program, faculty, students, ladies and gentlemen. A very good morning to one and all. I am Dr. Harita Bulineni, Scientist Division of Genetics, ICR IARI. On behalf of Genetics Club IARI, 15th Genetics Congress Trust and Indian Society of Genetics and Plant Breeding, I take the proud privilege of welcoming you all to this concluding ceremony of year-long birth bicentenary celebrations of Professor Gregor Johann Mendel, the founder of genetics. At the outset, it gives me immense pleasure to welcome the dignitaries onto the dais. Esteemed Chairman of the program, Professor R.B. Singh, former Chairman ASRB and former President National Academy of Agricultural Sciences. Chief guest of today's program, Professor Soumya Swaminathan, Chairperson MS Swaminathan Research Foundation, Chennai, former Chief Scientist, World Health Organization, Geneva. Guest of honor, Dr. R.P. Sharma, President, 15th Genetics Congress Trust. Dr. A.K. Singh, Director and Vice Chancellor, IRI, and Dr. D.K. Yadava, ADG Seats. May request the dignitaries to kindly grace the dais. Let us begin the program by lighting the ceremonial lamp, a cherished tradition that has been passed on through generations. May I request the dignitaries on the dais to kindly come forward and do the honor of lighting the ceremonial lamp, signifying the inauguration of this event. Lighting a lamp is a symbolic gesture signifying the triumph of light over darkness and the knowledge over ignorance. In this lamp, we find the embodiment of purity, wisdom, and truth. We invoke the divine presence and seek blessings from the higher realms. to welcome the dignitaries with a bouquet of flowers. To the Chairman, Professor R.B. Singh, sir. Thank you, sir. I would again request you to kindly present formal welcome address and also introduce the chairman and guest of honor to the house.
A very good morning to each one of you. On the occasion of the concluding function of Mendel's bicentenary birth celebration, I would like to extend a warm welcome to each one of you. It's our proud privilege that as the speaker and chief guest of this program, we have Dr. Soumya Swaminathan with us. She has served as Director General, Indian Council of Medical Research, and then World Health Organization. Currently, she is chairperson of the MSSRF in Chennai. Her contributions and a brief introduction will be given by the Honorable Chair of the function. I would like to extend a warm welcome to you, ma'am, for kindly agreeing to our request. And not taking, I remember I sent a WhatsApp message, and within no time, it didn't take even a second to get a reply, yes, I will come. So that was so nice of you to immediately responding to our request for this very important function. To chair the function, we have Professor R.B. Singh, Padma Bhushan, who is well known for his contribution to Indian agriculture, as former director of this institute, as former chairman of ASRB, and also member of Farmers Commission. And we have had a number of occasions to have him here as chairman. I have introduced to you in detail about him, about his contribution to Indian agriculture. It's phenomenal. And as member of the Farmers Commission, he made certain recommendations. A commission was chaired by Professor M.S. Swaminathan. It was never in past that Padma Shri Award was given to farmers. And it was with the recommendation of Farmers Commission and the chairpersonship of Professor Swaminathan and membership of Professor R.B. Singh that Padma Awards were started to be given to the farmers, and more than 12 farmers, 15 farmers have received Padma Award till date. So likewise on the minimum support price, the C2 plus 50% proposal, that as important recommendation came from the this particular commission. Thank you, sir, for accepting our invitation and kindly agreeing to grace this occasion to chair the session. We also have Professor R.P. Sharma, distinguished teacher and researcher, whose work on Drosophila wingless mutant is recognized world over. This discovery has paved the way to understand many genes in developmental involvement in developmental function, including cancer biology. Dr. Sharma has been a very eminent involved teacher at Division of Genetics earlier, and then later at National Center for Plant Biotechnology. He headed the center as director, National Research Center on Plant Biotechnology. Now it is National Institute of Plant Biotechnology. He is a person who is fully devoted to cause of science. Even at this advanced stage, he keeps us triggering for one or the other thing. One of the important, intervention that he made was about a tilling project, through which we have now come out with herbicide tolerant mutant for the first time, which has got great commercial potential as well as great value for direct seed rice to reduce the irrigation requirement, and almost by 35 to 40%. So thank you, sir, for being here with us. We also have Dr. D.K. Adva, Assistant Director General Seeds, who is a close friend of this institute. He has been in this institute for very long time, an eminent master reader. Thank you, Dr. Yadava, for joining us. In audience, we have Professor V.P. Singh, Padma Shri, and he is well known for his contribution to basmati rice research and development. Today, India has gone to a height of 38,000 crores annual forex earning through export of basmati rice. The foundation for this was laid by Professor Swaminathan in late 60s when he conceptualized the idea of combining the quality of traditional basmati into high yielding background. Then his student Dr. Siddiq, Professor V.P. Singh, Dr. Zaman, and to follow, we joined the group, and the kind of contribution that has come from this group is really enormous. We also have Dr. Rana from Bioversity International, my colleague, Dr. Brahmanand, Dr. Kaur, Dr. Anupma, Dean, and Dr. Viswanathan, Joint Director Research, Mr. Pushpan, Joint Director Administration, Dr. Gopala, Head Division of Genetics. This program, friends, as you know, and as Harita mentioned, was initiated a year back, exactly on the same date, and together with Genetics Club, 15th Genetics Congress, then we had Indian Society of Genetics and Plant Breeding, and the Protection of Plant Varieties and Farmer Rights Authority. All these organizations, they join hands together to celebrate Mendel's birth bicentenary. And today, after completing 1 year, we had a very good symposium in the beginning, and it was one day deliberation, excellent presentation were made, and now we are at the concluding day of this program. Once again, I would like to extend a warm welcome to each one of you. I also have Dr. S.R. Bhatt. Thank you, sir, for joining. He has been a big support, and the idea of the celebration and also the theme for celebration was primarily given by him, tendering the Mendel's garden for the welfare of society, human society. Dr. S.M.S. Tomar, our teacher and a eminent cytogeneticist, wheat cytogeneticist. So I welcome once again each one of you, all the professors, heads of the divisions, the students. Ma'am, what you see here, this young brigade of the students, this is for the first time IRI after 100 years has started a bachelor program in agriculture and in community science, BTech biotechnology and BTech agriculture engineering. So these are the UG students mostly you see here who are sitting, and it's a great opportunity for them to listen to you and get inspired. Thank you all once again, and we look forward for this wonderful proceeding. Thank you.
Thank you, sir. May I now request Honorable Chairman of the session, Professor R.B. Singh, to kindly introduce the chief guest to the gathering.
Honorable Chief Guest, Dr. Soumya Swaminathan, respected Dr. R.P. Sharma, President of the 15th Genetics Congress Trust, distinguished Director of the Institute, Professor A.K. Singh, of course, Genetics Club, the head of the Division of Genetics, Dr. Gopala Krishnan, of course, very distinguished colleagues and friends who are sitting here, VP and other colleagues, each one of you, my dear students, press media, ladies and gentlemen. Foremost, I must congratulate the Genetics Club, the 15th Genetics Congress Trust, the Indian Society of Genetics and Plant Breeding, for this most historic event that you have organized and celebrated it today on the birth bicentenary of Gregor Johann Mendel, the father of genetics. Genetics is the science of life and development. As a matter of fact, in this process then, I have the privilege and honor of introducing a person who is equally brilliant, which proves that science is that science of genetics is truly the science of life. As a matter of fact, when we look at a great and shining scientist like Professor Soumya Swaminathan, and when we look at the heritage and so on, it makes you really realize that there is something which we call like begets like. And particularly when you are sitting in this room and in the Institute of IRI and Genetics Division and so on, you just cannot forget. You just cannot miss. Even if you want to, I want to remember our mentor, our guide, the world guide, in fact, if I can mention, the father of Green Revolution, the person who saved millions of people's lives, the person who invigorated a large number of people here and abroad and everywhere in the world. Unparalleled, unmatched leader of genetics, and none other than Professor M.S. Swaminathan, and Professor M.S. Swaminathan's daughter, Dr. Soumya Swaminathan. As a matter of fact, this is where I said there are some genetic rules which are proven time and again. And here again, what Mendel discovered and the genetic rule of transition or transfer or heritage or the generation to generation progress. Even in old days when there were discussions about Darwin and Mendelian law, Sir Fisher used to write about the controversies and so on and so forth. But here I say the fact proves itself. As a matter of fact, even if I want to be very brief about Dr. Soumya's introduction, I cannot help but to mention a few very major important things. Dr. Soumya Swaminathan is a highly esteemed physician, scientist with significant contributions to global health leadership, with more than 30 years of experience, with a remarkable background in clinical care, research and policy development. Dr. Swaminathan has been at the forefront of advancing TB and TB/HIV patient care and played a pivotal role in leading critical initiatives during the COVID-19 pandemic. As a matter of fact, the COVID-19 pandemic, when everyone thinks of building back better, the kind of leadership which was shown by Soumya Swaminathan is something amazing. But let me go back a few steps backward to show that the journey that she had made in the field of medical sciences began with a strong foundation that was really laid in medicine while she graduated with an MBBS degree from Armed Forces Medical College, Pune University, India in 1980. She pursued further specialization in pediatrics, obtaining MD from the prestigious All India Institute of Medical Sciences here in New Delhi. Driven by her passion for medical research, she undertook a fellowship in pediatric pulmonology at the Children's Hospital of Los Angeles University of Southern California, USA in 1989. Her thirst for knowledge and commitment to excellence earned her fellowship from esteemed academies, including the National Academy of Sciences of India, Indian Academy of Sciences, and many others. As a matter of fact, 2-3 major universities abroad have granted her the Doctor of Science degree also in recognition of her outstanding contributions. Dr. Soumya Swaminathan's early career showcased her unwavering dedication to tuberculosis research. As a matter of fact, she is the most known tuberculosis research in the whole world, particularly in Asia and Southeast Asia, serving as Assistant Director and Deputy Director at the Tuberculosis Research Center in Chennai. Her work significantly advanced the field of tuberculosis and HIV/AIDS, Director Senior Grade and Head of the Division of HIV/AIDS, further amplifying her impact on these two ailments and as a way how to manage and fight these real major maladies. Dr. Soumya Swaminathan's leadership trajectory reached new heights. As a matter of fact, when she joined the World Health Organization, as a matter of fact, until she joined WHO was doing the mandatory kind of activities and roles that they were playing. But she totally revolutionized the system. As a matter of fact, first, of course, as a Deputy Director General of Programs, she played a critical role in guiding the WHO efforts and addressing the global health challenges, particularly that was the time when we were fighting with the COVID pandemic. But then, most important, that she was, as a chief scientist at WHO, she elevated her impact and she made it really known that in digital health and fostering meaningful collaboration with the global scientific community, you can really join the whole world together. One world, one health, and one system. And that was the WHO transformation, which nobody else had brought before. And I think, please, I would like you to clap with Soumya, because changing a United Nations system, which has been considered as always the leader for the health management, but the kind of transformation which science can bring, only science-led, that is evidence and informed policy matters she was able to bring into the council, that she was able to bring for scientific management in the WHO is something unique. No one else had done it before. During the COVID-19 pandemic, as you all know, Madam Swaminathan's leadership and expertise shone brightly. She led the groundbreaking COVAX initiative, facilitating equitable access to COVID-19 vaccines for developing nations. That is science for humanity, science product for serving the unreached. Reaching the unreached was the effort, but she was able to prove to be acting at the ground level. Her guidance was pivotal in implementing the WHO R&D blueprint and driving the solidarity trials, which I think this solidarity trials again is a unique system that she was able to undertake and initiate. Her strategic approach for science communication and the Living and Smart initiative significantly enhanced WHO's normative work, making it agile, high quality, impactful, and of course, which is pro-human. Soumya ji exceptional academic achievements garnered her numerous honors and awards. If I start reading the list of medals and awards, that will take another half an hour. I want to just only tell you that I have still to see a person, particularly in medical sciences or in many sciences, who might have earned as many medals and scholarships and as many accolades as she has been able to really earn. As a matter of fact, she received the President's Gold Medal for Academic Excellence during her graduate medical school and prestigious fellowships from esteemed national and international academies. In conclusion, Dr. Soumya Swaminathan's remarkable journey as a physician and scientist and global health leader has left an indelible mark on the field of public health. Her groundbreaking contributions in TB and TB/HIV patients, really taking care of them, strategic leadership during the COVID-19 pandemic, and transformative initiative at the World Health Organization have earned her widespread recognition, and improving global health continues to inspire and influence positive change worldwide. Soumya ji, you are a source of inspiration We all bow to you and pray that you continue guiding, inspiring, and really helping the humanity at large for the best of the service that you have been providing. Thank you so much.
Thank you, sir, for the wonderful introduction of a wonderful person. Ma'am, we are eagerly waiting to hear from you. So I would now invite you to kindly deliver your lecture.
Namaskar, good afternoon. Respected Dr. R.B. Singh, thank you so much for that really very, very kind introduction. I don't think I deserved all the things that you were saying, but indeed you highlighted some of the key parts of my life that I will be proud of, I think, in the future. Dr. R.P. Sharma, Dr. A.K. Singh, Dr. Yadava, Dr. V.P. Singh, and many other senior colleagues as well as students. First of all, let me express my gratitude to the director for having invited me, because I cannot ever miss an opportunity to come back to IARI. It brings back a lot of memories. I grew up on this campus and was constantly moving between the botany department, the genetics department, the library, as well as the fields where we used to go on our cycles or go for a walk. And so it is always very, very inspiring and invigorating to come back to this institute. In fact, I should probably thank this institute and the environment, the students and the teachers and the young PhD scholars, many of whom went on later on to become world leaders in agriculture, but at that time it was an environment of science, of research, of a lot of excitement, because new technologies were being used to solve some of the problems that we had in feeding our population at that time. And I'm sure that is what actually motivated me to do research, because I cannot explain why, but from very early in life I wanted to be a researcher, though I didn't know that I would be a medical researcher. I was actually started off with an interest in genetics, and then wanted to be a veterinary physician, but ended up as a medical doctor. I did not do a PhD or pursue genetics subsequently, but rather I specialized in respiratory diseases, in pulmonology, and I had done pediatrics, and so my interest was in child health. But gradually, through my work in tuberculosis, I realized that our health is determined by many other factors actually outside the health system. So I want to talk a little bit about that today, as well as about science in general, as well as how genetics or genomics can help maybe solve some of the current challenges that we faced. Just as in the 60s it helped to increase the yields of rice and wheat, so that not only India became self-sufficient in food, but obviously then that spilled over to the whole world as well. Now, Gregor Mendel was of course the father of genetics, but also he, despite not having a formal training and a background in science, and really struggling between what he should be doing as a career, he was the first one really to use an experimental method to demonstrate what later on became the principles of genetics that he articulated, and also was the first one to use certain new statistical techniques to analyze what he was seeing. And naturally at that time, like many visionaries who were ahead of their time, his work was not recognized, and he was not really given that any credit for the work he had done. And it is today that we celebrate him as a father of modern genetics and so on. But it took a long time for people to really accept that his way of doing research, experimental research, was really the way to prove certain hypotheses. So today, of course, science has come a very long way, technology has come a very long way, and today we have tools that we could not have dreamt about maybe 20 or 30 years ago. But along with that, we also face challenges today globally that are going to affect all of us, not only the human species, but species, animal and plants as well. So if you really look at what are those big challenges, and these could be classified as public health challenges or health challenges, they are, I would start with climate change and global warming. We're already seeing what is happening all around the world. The heat waves in Europe are unprecedented. The kind of floods that we've seen here in Delhi as well as across North India, and the heat waves that we have been seeing in India and in other parts of Asia over the last few years. Climate, of course, will have huge impact, is already having huge impacts, not just due to the impact of natural disasters, which displaces millions of people, leads to loss of lives and livelihoods, but also through indirect ways, and that is through our food system. And so our food and nutrition security once again is going to be at risk, just like it was a few decades ago, because of the impact of climate on plants and their yields and so on. But also through the influence on vectors and vector-borne diseases. We now know that diseases like malaria and dengue are being seen in parts of the country or parts of the world where they were never seen before, because the mosquitoes could not survive at those temperatures or at those elevations. But as global warming increases, the mosquitoes are also going to adapt and change their where they are comfortable living, and therefore diseases will spread. We've seen outbreaks of cholera around the world, unprecedented outbreaks last year, which are attributed to unseasonal rains, flooding, etc. And at the same time, there's been a global shortage of cholera vaccine. So the WHO stockpile of the vaccine was not sufficient to distribute to all the countries that were asking for cholera vaccine. So unfortunately, while we talk about emerging infections, new infections, the risk of pandemics, we still have infections today that have not been, we have not been able to conquer. And cholera is one example, but also tuberculosis. And Dr. R.P. Singh mentioned my work on TB. I feel very sad that within a year for COVID, we were able to have more than 400 vaccine development programs that were ongoing, and eventually at least a couple of dozen, 2 dozen vaccines that had regulatory approval, all done within 12 to 18 months of a new virus being discovered. That just shows that with commitment, political commitment, funding, and global collaboration, because that's what happened. Scientists all over the world came together. In fact, many of them dropped what they were doing and started working on COVID. And the result was that we had the tools that we needed, vaccines, but also diagnostics and drugs that would help us come out of the pandemic. And today, if we feel comfortable, it's because we've been vaccinated, and we know that even if we get the infection, hopefully we will not get a very severe attack. Now, the same commitment has not happened in diseases like TB, but my hope is that because some of the technologies that were developed during COVID, like the point of care tests, today you can wake up in the morning, do a rapid test at home to know whether you have COVID or not, whether you should go to work or stay at home. If we had such a test for TB, which could be used at the person's home or close to the home, we could very quickly think about elimination. As you know, the Prime Minister has called for elimination of TB in India ahead of a global elimination deadline. So he has set a very ambitious deadline, but for that you need the tools. So you need the rapid diagnostic tests, you need a good vaccine. We are still using BCG, first used in 1921. So a 100-year-old vaccine that does have some protection in young babies, but beyond that it does not offer any protection to any of us as adults against TB. So we don't have a good vaccine, we still don't have a rapid diagnostic test which can be a point of care test, and we still do not have a treatment protocol that can be used easily by patients. It's a very long treatment, 6 months minimum, goes up to 2 years sometimes, and some of the drugs are quite toxic. So the hope is that given things like the new mRNA technology platforms, the amount of sequencing capacity that has been built in the country and around the world, and the diagnostic technologies, that we will be able to find solutions to diseases like TB, but also many other infectious diseases. We still have malaria, filariasis, dengue, chikungunya, and then of course we need to be prepared for any emerging pathogen, whether it's avian influenza. Recently they found an outbreak of avian influenza in cats in Hungary. Now, once that flu strain is able to adapt itself to humans and is able to transmit human to human, then you could have a very devastating influenza pandemic at any time. So I think I started with climate, but it's very much linked also to the other threat which faces us all, that at any time there can be another pandemic. It could be flu, it could be coronavirus, it could be one of at least 25 or so viral families that exists, and therefore the need for preparation is very important. R&D is very important, as well as the capacity to manufacture quickly, which of course India has. But then we also have a different set of challenges which are really related to what we call non-communicable diseases, which are diseases like diabetes, high blood pressure, heart disease, stroke, kidney failure, and so on. These are called non-communicable diseases, and these are the ones today that account for premature mortality around the world, but particularly in India. And when I was in the ICMR a few years ago, we did a state level disease burden estimation to see what is the disease burden. Actually, we need that data, because without data it's very difficult to formulate good policy. And the best way of collecting disease burden data is to have death statistics. You need birth and you also need death statistics, which describe also the cause of death. In the absence of that, because most of our states do not have a robust system of cause of death data, we have to resort to modeling, which always has some limitations. So anyway, with all of the data that was available in India, we came up with a state level disease burden estimation, which actually showed, this was in 2016 that report was released, it showed that most of the states had moved from communicable disease to non-communicable diseases. The transition, what is called as epidemiological transition, had happened. States like Kerala, Tamil Nadu, they started happening in the 80s, whereas states in the north probably were a little bit later. But still, the burden of disease today is shifting towards these non-communicable diseases. Infectious diseases are still there, and we also have, of course, still a massive problem of nutrition, particularly anemia, micronutrient deficiencies, as well as undernutrition, stunting, wasting, and at the same time, very, very troubling is the increase in obesity levels that we are seeing, very rapid rise in obesity. Many of you would have seen the recent publication of the INDIAB study, the India Diabetes study that has been running for 15 years actually, funded by the ICMR, which showed that the prevalence of diabetes in the population in India is 11% of adults over the age of 18, and pre-diabetes another 15%. Hypertension was seen in 35% of adults, and lipid abnormalities like cholesterol, etc., were seen in 85% of people. So if you really think about it, this means there's something fundamentally wrong with our food system, because why have we gone in the last 30 years from a country with low rates of diabetes and all of these risk factors today to it's becoming a really, it's an epidemic or a pandemic, if you can call it, and it will overburden the health system. Today we have 100 million diabetics in the country and another 131 million pre-diabetic. All of them will become diabetic. So you can imagine, you know, hundreds of millions of people who will require medical care, and it's very common to get complications if, you know, the treatment is not regular. So we need to think about the risk factors. So the determinants of health, this could be social determinants, environmental determinants, and things like your the water, access to safe water, sanitation, housing, but very importantly, air pollution. Air pollution has been shown in data from NFHS that has been analyzed to be linked with especially household air pollution, so more common in the poor households, linked with diabetes because it sets up a pro-inflammatory mechanism. So exposure to air pollution, we underestimate the impacts it has on our health, whether it's the brain or whether it's cardiovascular system or the fetus. But also nutrition is extremely important. And today what we are eating, most of us, in fact the National Institute of Nutrition is saying that less than 2% of Indians are consuming a diet which they recommend. So most of us are not consuming a healthy diet or a balanced diet. We're eating too much of carbohydrate, not enough of fruits and vegetables, and probably lacking a bit in protein as well as in micronutrients. So I think the challenge really for us today is not just food security, because I think that we have achieved, but nutrition security, where every Indian, rather everybody in the world, should have access to safe and nutritious and balanced food. A recent report has been released by the UN also, and has shown that the number of undernourished people has gone up. People who are not even getting 2 square meals a day, and the number of people who are obese is also about 2 billion people today in the world. So I think let's remember the social determinants and environmental determinants of health, and remember that food is an important determinant of health, and if this goes wrong, then you are left with disease. And the health system of course can deal with disease, but it cannot deal with this upstream, which is where all of you have an important role to play. People who work in agriculture, in environment, in road safety, also in building engineering. We know today that the quality of the air that we breathe indoor and outdoor is important. There's a lot of new work that's been done because of COVID to understand how these respiratory pathogens transmit. And of course 1 year ago we would not be sitting here like this without masks. Today we are all feeling more comfortable, but any respiratory pathogen will spread in a room like this, you know, unless there is attention paid to the air exchanges, etc. So again, that's new science that has come out during the pandemic, where biomedical engineers worked with biologists actually to generate models of how these viruses can spread. Now new technologies, and of course today we are talking about genetics and genomics, but we cannot forget about artificial intelligence. It's there in the papers every day, quantum computing. When you put all of these together, biotechnology, artificial intelligence and quantum computing, and today the generative artificial intelligence or deep learning, then you get very powerful combination of new technologies which can be used probably to solve some of these problems that we've talked about, but also come up with their own ethical, legal and social and regulatory challenges. So let's remember that any new technology has a lot of positives usually, but can also have risks, and these risks need to be addressed. They need to be, this is the same with GMO foods also, it's the same debate. And when we were developing these COVID vaccines and they had to be approved by the WHO, and people used to ask questions about how can you be confident that these vaccines are good enough and safe enough to be used. They have been developed so fast that it's impossible to have done the studies properly. So there was a big responsibility, and what we needed to do then was to balance the risks versus the benefits. So in any new technology, we always have to balance the risks versus the benefits. Nothing is 100% effective, nothing is ever 100% safe. And you could always have a 0.001% chance of something going wrong, but it's important to recognize that and to acknowledge it and to develop systems to pick up if anything goes wrong. So for example, when you roll out a new vaccine or a new drug, you always have a pharmacovigilance system built in, which is monitoring the population, documenting any serious side effects, and the decision makers need to review that periodically. At any time, if you feel that the side effects are not worth or more than the benefits to the population, then you need to take a decision on whether to go ahead or not. So I think this principle is very important, and while I was at the WHO, I think Sir mentioned that we had set up a science council, and the idea we had, of course I was asked to create the science division, and one of the things that I decided was important was to really look at these type of new technologies and look at what are the scientific benefits and how should we be moving ahead, how do we use genome editing, for example, to improve health. We know that today the CRISPR technology can be used to deal with genetic diseases which are which are monogenic, where you can actually take out that gene and replace it with a normal gene. So there are trials going on now for diseases like sickle cell anemia and thalassemia and a few others, where there is potential today to cure hereditary disease thanks to this new technology. But on the other hand, we also know that this type of gene editing, if it is done in the germline, in the embryo or the ovary, or if it is a heritable gene editing, then we are opening up something that we are not sure what it will lead to. And you all are familiar with the case where Dr. Hu Jiankei, the Chinese scientist, had done a CRISPR based gene editing for twin babies, and the reason he did it was to prevent them from getting HIV. So he edited the gene CCR5, which is a surface receptor on the T cell, and he said that it will make them resistant to HIV. But because it was done in the embryo, and because it was a heritable germline gene editing, it raised a huge international ethical controversy. Of course, he underwent a lot of punishment, etc. in China, but it also led to the WHO setting up a committee to look at the ethical, scientific as well as ethical, legal, regulatory and social aspects of gene editing, and we published that report in 2021. It's an excellent report because it doesn't tell you what to do or what you should not do, but it tells you when you do human gene editing, how should a country's scientific system really look at regulating that. And it's classified the gene editing into different types of gene editing. Somatic gene editing, I mentioned diseases like thalassemia and sickle cell anemia, where you can cure a child or even an adult. There have been cases where HIV infected people, at least 3 or 4 cases in the world, have been cured of their HIV by bone marrow transplant. Of course, it was not a CRISPR kind of treatment. And there are other such very serious diseases which you can use CRISPR to cure, then you should be able to do that. So we want to encourage research which leads to these type of medical breakthroughs and can cure diseases. But at the same time, there are also gene editing, like I said, which is done on the germline, which is heritable, or which is done on a fetus. Again, in the fetus, it could be on the somatic cell line or the germline. And finally, you could use CRISPR for a non-DNA gene editing, but it is further downstream. You could also look at the epigenetic modifications and so on. So we have to take it as a case by case, and each country needs to set up a system to be able to regulate and allow science to proceed. Don't have to ban the research. I think that was very clear. But at the same time, many countries have banned the germline gene editing while they allow the somatic gene editing to proceed. And this committee also asked the WHO to set up mechanisms for a registry, so that all the gene editing, human gene editing studies around the world could be captured in one registry. You know that WHO maintains International Clinical Trials Registry platform, which takes and hosts all clinical trials, human trials that are going on around the world. So like India, for example, has an Indian Clinical Trial Registry that's maintained by the ICMR, but the data also goes to WHO so that it's in the global registry. So they wanted one part of that to look at gene editing experiments, and it's a little complicated because you'll have to start with what is happening in the lab from very basic science all the way through to clinical trials. The other recommendation was that there should be a whistleblower policy globally, and there should be an agency to which a whistleblower can actually inform if they find out that there's some unethical research going on, and this was based on the experience of that Chinese scientist. But there have been other scientists also who have said they're going to go ahead and do the work. And the third was that there needs to be not just national regulations, but some kind of global body or regulatory, maybe it's the WHO or some other body that oversees how the research on gene editing, human gene editing is proceeding. Now of course I think for plants it's different. You're doing a lot of work here using CRISPR, and those varieties are going into field trials, which is really good because it can help to address some of the challenges we have today to meet our nutritional needs. So, but when it comes to clinical, you're dealing directly in human beings, and once you make a change, it's permanent. So that's why it's important. Similarly, there was also the artificial intelligence. That this was again 3 years ago. We decided that the other main technology that we could see will have a big impact is artificial intelligence. So we put up another committee actually to look at the medical applications of artificial intelligence and how can that be regulated. And today, as you know, everybody is discussing how do you regulate AI, which today's people fear might become like a superhuman, etc. And especially now that we have generative AI, you have seen the power of ChatGPT and so on. This is going to keep growing. And so very recently, in fact, the UN Secretary General, I think yesterday or day before, has put out a call now to establish a UN body just to regulate artificial intelligence. Because the advantage of the UN, of course, is that it is made up of member states, and so every country gets a voice and is able to contribute to the development of policy. But as far as the health aspects are concerned, again we did put out a framework for how an artificial intelligence algorithm can be developed for health applications. What are the pitfalls, what are the biases which need to be kept in mind? Because as you know, today most AI algorithms are trained on Western data sets. They are trained on Caucasian data sets. They may not be applicable for us across the world for different races or ethnicities. And so it's very important that before we just adopt something and start using it, we must be confident that it is actually doing what it says it will do. Otherwise, if there is a lot of bias built into the algorithm, then we will be doing a disservice to people here by bringing those algorithms and trying to use them either for diagnosis. Today, of course, we are using AI already for things like reading chest x-rays, reading pathology slides, and it can be very useful because you can save a lot of time of the radiologist or the pathologist. These are usually in short supply in rural areas. We don't have radiologists and pathologists, and so x-rays sometimes are not read for a long time. Pathology slides have to travel somewhere far away to be read. So certainly AI could make a massive difference in providing results quickly. Of course, it always needs the oversight of a human, and in fact very recently we were reviewing some AI applications for TB, and we found that even cough, just recording your cough and training the AI to see whether this cough could be due to TB or it could be due to COVID or it could be due to something else. People are trying to work on that. It's very difficult, but definitely people are working on that. Another challenge that we are facing and we will continue to see is mental health, and particularly among young people. And I think IARI, Dr. Singh, is a very large growing institution. As you mentioned, a lot of undergraduate students. I think an attention to mental health is important. We've seen that after the pandemic, the levels of anxiety and depression, particularly in the 18 to 25 year age group, has shown a big increase, and therefore we need to acknowledge it, address it, have ways of people to talk about mental health. I think there's a lot of stigma still in society. People do not want to acknowledge or even say that they could be feeling, I could be feeling depressed, or I'm feeling, and I cannot explain why I'm feeling so low, etc. So I think a lot more awareness, a lot more open discussions, and will help to address. And where people need further counseling, of course, they need to be referred. Now again, genetics has a role to play because, as you know, some diseases are polygenic, they are not monogenic. So monogenic diseases, we talked about things like sickle cell disease, Huntington's chorea, which is fatal disease, which is a neurological autosomal dominant disease. You have autosomal recessive, you have also sex-linked recessive diseases. But for things like depression, schizophrenia, diabetes, Alzheimer's and so on, we still don't have one gene, but it's probably a combination of the polymorphisms that cause you to be more prone to that. It doesn't mean that everybody who has those genes will get it. So there is a big debate today in population genetics. Should we screen everybody? Should everybody go now today and have your genome sequenced? How many of you would like to do that? So yes, well, minority of people want to go and get their genome sequenced. And you know, there's a natural tendency for us not to want to know bad news, right? You don't want to know what is in store. Do your genes carry something which will predispose you? But you know, there have been randomized trials in the US, very interesting design of the trial, where they looked at people, they looked at two groups of people. One were people who already had a disease and they had come to the hospital and they were seeing a doctor for some problem. The other was healthy adults, and they randomized both these into two groups, one that had a whole genome sequencing done and one that did not, or yes, they did not have it done. And then they saw how the doctors were managing these people. The doctors were trained a little bit in genetic counseling and all. And one of the findings was that there was no negative impact on the people who had the genome sequencing done. In fact, it was the people who did not get it done were very unhappy because they had also wanted it done. When they entered the study, I think they were motivated. And they also showed that by doing this whole genome sequencing, in at least 15 to 20% of people, you pick up a gene which is related to a condition which can cause problems, health problems. And when they went back and explored, they found that family history was also there for those people, that some of them were already suffering from symptoms, but they didn't know that it was related to this genetic problem. And for the others, they were now aware that they had this gene and that they could develop, whether it was some kind of eye problem in the future or it was a musculoskeletal problem. So of course, cancer is one of the most common reasons for for advising somebody to go and get a genetic sequencing done. And we all know that the famous case of Angelina Jolie, who then decided to go for a bilateral mastectomy because I think her mother and aunt and few people in her family had died of breast cancer. So when she found that she was carrying the BRCA gene, she decided that she would have a preventive bilateral mastectomy so that there would be no chance of developing breast cancer. After that happened and she was very public about it, there was a lot of people got motivated actually to go in for getting the cancer screening done. And the advantage of course is that if you do it, then you can have regular preventive checkups, you can screen yourself regularly, and if necessary then go in for something like this, which is a preemptive surgery, which actually takes out the organ so that you don't develop the cancer. So there are many applications in for individuals, but at the population level it is not, it's still debatable whether people should be advised to go and get a gene sequence done. Of course it's also the cost, but we know that today for about I think $1,000 or maybe it is even less, you can get a whole genome sequence done. Whereas we know that in the beginning, when the first whole genome sequence of the human was put together, it cost, I think, I don't know, $2 or $3 billion to sequence one genome. So the cost will come down and will continue to come down. The technology is improving. Today you have sequencers which can be carried in a backpack. And so there are many applications today for genetics other than dealing with human genetic diseases, where you can use it for, and I'll give you one example, and that is for antimicrobial resistance or antibiotic resistance, which as you know, you're probably aware is a huge threat. There is estimated that 50 million people will be dying of AMR by 2050, that there will be trillions of dollars lost in global economy and so on, because it will be like going back to the pre-antibiotic era. And so the use of genomics could help. Of course, again, it's one area where agriculture and health are very much linked, because as you know, antimicrobial resistance develops because of exposure of bacteria to antibiotics, could be in the soil, could be in the feed. And so the use of antibiotics as growth promoters in poultry or livestock, etc., obviously it does contribute, and there are antibiotics that are not to be used in animals that have to be reserved for humans, like polymyxin B. The rate of development of new antibiotics is far slower than the rate at which we are developing resistance, because no big company today, no pharma company wants to invest in antibiotics, because they know a new antibiotic will be reserved for use in very few people, because it will be kept as a reserve drug. It will not be widely used, it will not make a lot of money in the market, it will not be a top seller for the company, and therefore big companies, big pharma companies have all withdrawn themselves from developing new antibiotics in the last maybe 15 years or so, and therefore it's a huge problem, because then somebody has to do it, and the people who are doing it are the small companies, the small biotechs, who are not able to really survive this whole process of investing in R&D, and then at the end of it they don't get much of a profit. So this is where governments need to come in, and even the G20 has discussed antimicrobial resistance to say how can we work as a public-private partnership where the government actually invests money and helps these companies to develop antibiotics, but also make sure that the companies don't just fold up because they are not able to make any kind of sales or profit. But definitely, whole genome sequencing has a big role to play today in pathogen surveillance. We saw it in COVID. We can see the same applications in wastewater surveillance, environmental surveillance, so that we can keep track of the pathogens. It has been used for polio for a long time. The country has been doing wastewater surveillance for polio, and to maintain the, we need to keep checking that polio viruses are not circulating. So that can be extended to other pathogens actually for use to predict, and in certain cities which used wastewater surveillance for COVID, they were able to predict a wave. So 1 week before the wave hit the population, they could see the increasing levels of COVID in the wastewater. So that again is a very good, same thing can be done for antimicrobial resistance. The data also needs to be made publicly available, it needs to be shared, it needs to be transparent so that it can inform action, and we can also use it today. Genetic tools combined with artificial intelligence are being used for drug development. They're being used also to predict which drug will work the best in a particular disease and so on. So I think there is no doubt that the field of genetics and genomics can serve public health, including in developing countries. There are many applications. Haven't gone into all of them today, just gave a few examples, but the potential is enormous. But we have to remember the other side which I talked about, which was the ethics side of it and the regulatory side of how we do these, where we have to have a balance between promoting research for good and at the same time making sure that if there's any harm, then we are able to capture that very quickly and take action. But also we need to look at equity, because sometimes you see announcements from big companies that they have developed a cure for some disease, a genetic cure, spinal muscular atrophy. These are good examples of terrible diseases which affect small children. I mean, they are congenital, they are hereditary, they manifest in early childhood, progressive muscle weakness and leading to death ultimately. So treatments have been developed. They cost between $1.5 to $2 million for that treatment. So clearly this is unaffordable for people living in countries, most countries around the world, or even in the developed world. I think very few people can afford $2 million for a treatment. So what is the point of developing such treatments which actually don't reach people? So I think we also have to think about how do we use technology to democratize access, improve access to drugs, to vaccines, to health products. So that is equity has to be kept in mind anytime new technologies are developed. And then finally, I think one is today living in a world of where there's unfortunately a lot of misinformation and disinformation. There are anti-science groups, anti-vaccine groups which operate luckily less in our country, but no country is immune, because today we live in a world connected by social media, and it takes only few minutes for messages to travel from one part of the world to the other. And if you just scroll through YouTube and WhatsApp and all that, every day you will come across clearly some pieces of new information there which are not at all scientific or rational, but they are made to look or to appear so. So I think young people today have a big challenge because of this overload of information that we get because of being connected all the time. And you have to be able to discriminate what is true from what is false. And it's not always easy, but the best way is to develop a critical thinking mind and to always ask yourself, could this be plausible? Is it rational? Does it, sound scientific? So I remember during the time that vaccines were being developed, even before we had COVID vaccines, we had anti-vax groups actually putting out messages saying this is all a conspiracy. Bill Gates is putting chips into everybody. These were the kind of crazy conspiracies, but they are very sophisticated. Some of these things, of course, you read it and you don't believe it, but they can also make videos which are extremely believable, and they get pseudoscientists who put on white coats and come and talk about, this RNA is going to get into your DNA and then it will do this to you and that to you. And we know that around the world there were many politicians also who were making statements that did not encourage people actually to take up vaccination. So again, we were lucky that our country did extremely well in terms of COVID vaccination, the speed at which we developed, and also the coverage which was achieved was very, very high compared to many other developed countries. So we can take pride in that, but it is a threat. I think the anti-science misinformation kind of thing is not going to go away. It's not just because of COVID. I think it is the world that we live in today which is very complex, and so it is again a responsibility. I think for our generation, we were spared of that because I think we were not constantly with our phones being exposed to 1,000 messages a minute. We could concentrate on we had to download and then read, even when after we got internet, and before that it was go to the library and read or borrow a book, etc. So the world today is very different, but too much information is not always a good thing, because it's always a mix out there. And so again, I think this is something that all scientists, and you're all budding scientists, will have a responsibility to not only being very clear yourself, but educating your peers and your family and society in general about not believing everything that somebody sends you by WhatsApp. And I know that the power of WhatsApp, I was talking to somebody from one of the small West African countries which had a vaccine coverage rate of 3%, only 3% of the population. And when I asked her, she said it was because of the messages circulating on WhatsApp, that people believed those more than what they believed from the public health authorities, and so they just refused. And in fact, even childhood vaccination went down because they lost trust. They thought government will inject something without their knowledge. So trust between people in society and trust between those who are leaders, whether they are political leaders or scientific leaders or public health leaders, and the rest of society and community is extremely important, and that has to be built over a period of time. It doesn't happen overnight, But I think for the future, for whatever challenges we spoke about, as well as the use of new technologies, it has to be a partnership between science and society, scientists and people in the communities who really must engage with these topics and decide on what is the best way forward. And again, what I always try to remember is, do the benefits outweigh the risks, and also who's being benefited? Will this new thing be able to be equitably used by people regardless of, you know, their socioeconomic status, etc. So I think few philosophical and moral questions also one needs to ask before we accept every new technology. But we're living in an age where technology is growing by leaps and bounds, and so we also have to move very fast to be able to address some of these complex issues that come with it. I'm sure Gregor Mendel could not have imagined a day 200 years later that we would be living in this, where on your fingertips you can do a whole genome sequence very quickly, whether it's a plant or an animal or even a human. But along with that, you know, the human race also now has a lot more responsibility resting on our shoulders. Thank you very much again, Dr. Singh, and everyone here for the patient. Thank you.
Thank you so much, ma'am, for for gracing us with your gracious presence and delivering such an inspiring and socially relevant message. May I now request the chairman for your valuable remarks.
Friends, before I make any remarks, I would like to congratulate Dr. Soumya Swaminathan for a wonderful, pragmatic, practical speech, which is a guide for each one of us for everyday living. I would request you to give her a standing ovation, please. Soumya ji, you deserve it. The way you were able to convey it to us, we are safer than a moment ago. So thank you so much. Thank you. And I will say again that Mendel, 200 years ago, of course, wherever you are, you continue to guide us through that genetics, and you keep also warning us that probably you don't have to use anything blindly, and that is the message which has really been carried through. Anything that we follow in the process, whether it is gene editing or it is the health challenge being with the kind of communicable or non-communicable diseases, whether it is biotic or abiotic, stress-led, or whether it is predictable or non-predictable, whether it is global or local. We all know local and global are no more different, and they are all interconnected. So under these very difficult conditions and varied conditions and so on and so forth, only one way is to go about. That is, put the science to serve you. Put whatever is doubtful to the rigorous scientific test. And once the science evidence, which is scientifically proven and is available, then you should be able to see which way to go about it. Make policy, take your decision based on science, not on any other consideration. So this is a very strong message which I think has to be really followed. But to do that, science automatically has to depend on reliable data. If you do not have the reliable data, what will those analyticals and multiple computers will be able to do it for you? If the data is wrong, then the outcome is wrong. So what is important, another point which came out very clearly, that we must be able to have reliable data for disease burden. And today, we feel two major regions, and which is connected with agriculture in a very big way, that undernutrition or malnutrition, particularly undernutrition, is a major cause of several of the diseases that we are pursuing, non-communicable diseases and so on and so forth. And mind you, I wish to underline, which Soumyaji was able to also indicate very clearly, that today no other country suffers from that undernutrition more than India does. Do you know, I have said it in this hall several times, that 50% of the world's wasted and stunted children are our own Indian children. Mind you, the burden of these stunted and wasted children for years to come to the family, to the children themselves, and to the system is so high. And therefore, any policy that has to be made, keep this in fact. And there is also a fact known that if you spend $1 in managing the undernutrition of a child, you benefit by $16 to $50. So the return, the rate of return for investing and controlling the undernutrition or stunting or a wasting of a child is extremely high. No other investment pays you back to the society as much as this does. The third thing which appeared very clearly again in the communication, that please respect, it is one health, one world. Whether it is microbe, whether the microbe generation is for the climate change stress, biotic or abiotic stresses and so on and so forth, new microorganisms originating, multiplying and so on and so forth, whether it is impacting a microbe system by itself, or it is impacting a plant or soil or human or animal or anything, they are all interrelated. Epigenetic systems, the zoonotic multiplications and so on and so forth, all these aspects are interrelated. Therefore, what is needed today, that all scientists, biologists who are working and interacting with this, they should take a system approach, a human health system approach which is based on one health, one world. So this is system, food, nutrition. Food is not enough. Nutrition, pollution, the sustainability, the ecological factors, water availability and water pollution, digestive system, all these are interrelated. So you should be able to go through the entire process of looking at what pollutants, what is the impact, what food system, social environmental systems are impacting human health, social and environmental factors impacting human health. This has to be kept in mind. Similarly, therefore, when we reorganize, now we are reorganizing our educational system. Our young students are here, my dear students. Please remember, today there is no isolation from one field to the other. Interdisciplinary, system-based approach is absolutely essential. Science, mathematics, engineering, all medicine, agriculture, you name it, they all have to be seen together. And when you study, see the interconnectivity right from the beginning. And I request my teacher colleagues also that please change the method of teaching, way of teaching, bringing the system approach as a whole, so that 1 plus 1 is 11, and the synergistic interaction is multiplied, antagonistic interaction is minimized. This kind of approach will come once we know, and this is where, madam, the artificial intelligence that we talked about, how to go about to handle the artificial intelligence, and if there is a recommendation to the United Nations system by the Americans or by anyone to really establish a human regulatory system, also to look into how the artificial intelligence is impacting or would impact or will help the world as a whole is another major message that you have given. We should be able to see that this is used to balance the risk and safety, and balance it on the basis of knowledge, evidence. Therefore, I will say whether it is gene editing, whether it is the thalassemia or the sickle cell anemia management, or whether it is the ethical or the social aspects of anything of the germline or somatic mutations, they need a balanced approach. And mind you, also keep in mind that inequity is a major cause of multiplying the disparity. And that disparity is the cause of lot of degeneration in the system, social system as a whole, humanity as a whole. So all this is important. Of course, the point was made about mental health, whether the genic system we understand is the monogenic, polygenic, pleiotropic, polymorphic, whether it is, you see, all these understandings will help if you are able to analyze this correctly with the right data. And therefore, the randomized gene sequencing approach, if it is going to work and help, I think it will be a great approach, and we should be able to make it happen. The antimicrobial resistance management, which was mentioned, it is a serious threat for human welfare, and it has to be done most appropriately, and it needs the science social responsibility with the corporate social responsibility. Let the public-private sector, all industries must be put together to really look into the antimicrobial resistance build-up and the system approach and generate the right data which can be used world over. Of course, if you have information, make it sure the information is again science-based. It is not able to, if you are not able to discriminate, better use the best of the tools available, and so that once you have used the right tool, you have bred the trust. So if you breed the trust among each other, your doctor, yourself, your family, with each individual person concerned with you, then you are able to overcome the difficulty. I will stop here and let me tell you that ultimately what we need, the total integration of science and society. Let science and society be totally integrated. Without that, one cannot move beyond 1 inch further. Thank you very much, each one of you. Thank you for your attention.
Thank you so much, sir, for your insightful remarks. It's now time for felicitating our chief guest. So may I request the dignitaries on the dais to kindly come forward and do the honors of felicitating our today's chief guest, Professor Soumya Swaminathan, with a shawl and a memento as a token of our love and respect. I will now request our director, Dr. A.K. Singh, to kindly do the honor of felicitating our chairman of the session, Dr. R.B. Singh. I also request you, sir, to kindly felicitate Professor R.P. Sharma, sir, with a shawl and memento as a token of our love and respect. Thank you so much. Moving towards the conclusion of this memorable event, I would now request Dr. Gopalakrishnan, Head Division of Genetics, to kindly present formal words of thanks.
Thank you very much, Harita. Honorable Chairman of today's event, Professor R.V. Singh, our valued and honorable Chief Guest of the occasion, Professor Soumya Swaminathan, Guest of Honor and President of 15th Genetics Congress Trust, Dr. R.P. Sharma, our respected Director, Vice Chancellor, Dr. A.K. Singh, our beloved ADG Seeds, Dr. D.K. Yadav, Joint Directors of the Institute, our most valued guests from the sister institutes, the directors of sister institutes, project directors, heads and professors, ladies and gentlemen. It is my proud privilege to propose the vote of thanks. I, on behalf of the Genetics Club, IRI, and also the entire faculty and students of our institutes, and on my own behalf, extend a very hearty thanks to Professor Soumya Swaminathan for graciously accepting our invitation for delivering the Chief Guest address today. Ma'am, your lecture was very thought-provoking in terms of enlightening us with the challenges before us in this volatile, uncertain, complex and ambiguous world. Right from climate change to ChatGPT, you elaborated the points for us to ponder over for in times to come. Thank you very much, ma'am. I would like to extend our sincere thanks to Professor R.B. Singh for gracing the occasion by chairing and sharing your words of wisdom. Sir, your presence itself makes us so excited in terms of the experience you have and also the kind of wisdom you share with us on each of the occasions is very useful and thought-provoking for the students as well as the faculty members of this institute. Thank you very much, sir. I sincerely thank Professor R.P. Sharma, President, 15th Genetics Congress Trust, for his gracious presence, and also the 15th Genetics Congress Trust has been a partner, collaborator, and also the guiding force behind organizing this function. We have Professor S.R. Bhatt also with us, who has been involved in helping with the organization of all the activities during the year. Thank you very much, sir, and thank you very much for your kind support and also the constant guidance. I would like to sincerely thank our Assistant Director General Dr. D.K. Yadav, ADG Seeds, for his benign presence, and also for his help in mobilizing whatever resources we could do, which is one of the most hard tasks, which has been a challenging task for us in organizing the event. Thank you very much, sir, for the kind help and for standing behind us for conducting this program in an effective manner. I would like to thank our Director and Vice Chancellor, Dr. A.K. Singh, who has been the guiding force behind all the programs which we have conducted, right from the one-day seminar which we organized last year, and also whenever we go for his guidance, we get the solutions right there. Thank you very much, sir, for your kind guidance and constant encouragement. I would also like to thank our joint directors and AKMU for live streaming this program, and also the organization of the event which was held last year. And this commemoration event was not possible without the generous support from our co-organizers, which is the 15th Genetics Congress Trust, Indian Society of Genetics and Plant Breeding, and also a lot of cooperation from our faculty, alumni of Genetics Division, and also our sponsors which are listed. I would not take each one's name, who have contributed for smooth conduct of these events. At the end, I would like to end with a quote. Mendel was a tireless experimenter, and his experiments was driven by the innate curiosity which he had in experimenting. And one of the aspects of Mendel's mythology, which is in the literature, which is not an exaggeration, was his humility. So I would like to quote a couplet from Tirukural, from the 978th couplet, which talks about greatness. Paniyumam endrum perumai, sirumai, aniyumam thanne vendu, which translates as smallness adores and admires itself, whereas greatness is always humble. Thank you all for being patient and also for making this function a great success. Thank you. Thank you very much.
Thank you all for joining us and making this event a memorable event. Refreshments were arranged outside this auditorium. I request all of you to kindly join us and enjoy the refreshments.